Okay, qualitative chemical analysis. We've been talking about a lot of quantitative stuff. Qualitative analysis, we're just trying to identify what kinds of ions, which ions are present. And we can do this using selective precipitation. This is a variety of wet chemistry, because you get your hands wet when you do these things, right? We don't actually use this in practice much because we have instrumentation that does this faster. But the instruments are expensive. So if if you don't have the instrumentation, you can still do it the old-fashioned way. And it's good to understand the concept of this old-fashioned method, and especially since that's what your lab practical is going to be. Right? Okay, so what happens here? So we've got a sample containing a mixture of different cations. Here we're just calling them A, B, and C. And so you're going to add a precipitating agent that's going to remove one of the cations. So here we precipitated out cation A. It forms a precipitate, goes to the bottom of the test tube. So we can decant the liquid that contains ions B and C, put it in a new test tube, add a different precipitating agent, precipitate out cation B, decant that, and now we should have a solution that just contains cation A. And so we can separate the three ions using selective precipitation. So there's different groups here. Group 1, these are the insoluble chlorides. So you treat the mixture with 6 molar hydrochloric acid. Most chlorides are soluble except silver, lead 2, and mercury 1. Those form insoluble chlorides. So if you have one of these present, you can use 6 molar HCl to precipitate that. The second group is the acid-insoluble sulfides. So you treat the mixture, it's acidic already because you already added HCl to remove any of the first group. You're going to treat it with hydrosulfuric acid, which is a weak diprotic acid. The concentration of the sulfide is pH dependent, right? So if you have low pH, because you have high hydrogen ion concentration, the sulfide ion concentration is going to be low, and only the most insoluble metal sulfides will precipitate. And those would be mercury 2, cadmium 2, bismuth 3, copper 2, tin 4, arsenic 3, lead 2, and antimony 3. And here they're giving us pictures of what those different precipitates look like. So ammonium sulfide is just a clear solution. There's no precipitate. Cadmium, antimony, and lead will precipitate. Next, you do the base-insoluble sulfides. So you're going to add base, probably hydroxide, and that will increase the sulfide ion concentration. So now you're going to get more ions being precipitated. You'll get the iron, cobalt, zinc, manganese, and nickel will precipitate with sulfides, and the hydroxide will precipitate chromium, iron 3, and aluminum. And then again, you remove the solids. So at this point, you've got alkali and alkaline earth metals left. You've pretty much precipitated out everything else. You can get rid of the alkaline earth metals using ammonium phosphate. So the magnesium, calcium, and barium will precipitate with phosphate. You pull those out. Now you've got sodium ions, lithium ions, and ammonium ions. You can't precipitate these ions. They don't form insoluble compounds with anything. So how do you identify them? Well, you use a flame test. So you've got sodium or lithium ions in here. Doesn't it seem like potassium should be in there as well? Because then it talks about sodium and potassium. Sodium will give you this bright orange flame. Potassium is a lot more subtle. It gives sort of a lavender flame. Yeah, I think there's something wrong with this slide. Yeah, it's supposed to be potassium, not lithium, I'm pretty sure. Because look at the flow chart here. Down here, you've got the alkali metals, metal ions, sodium, potassium, and ammonium. So I think that was supposed to be potassium. So starting out with some combination of these, you can separate out group 1, the ones that are in purple, by adding chloride as hydrochloric acid. You can separate these out by adding H2S. You can separate these out by adding hydroxide ions so that you get the pH up to 8. And these guys you can precipitate, come on, pointer. The green ones down there you can precipitate using ammonium phosphate.
How are you testing for ammonium?
You're not going to be testing for the ammonium most likely because you're adding ammonium here.
Okay.
But it does show up here. I guess if you knew something was in there and you didn't get a orange or lavender flame, you could assume that there was ammonium in there.